Hello children, today we will learn about uniform circular motion. Uniform circular motion. We have studied about the uniform motion. So, what should be the difference between uniform circular motion and uniform motion? This uniform motion was linear motion, that is in a straight line. So they are quite different with each other. How? In uniform motion or linear motion, we were also calling it as uniform velocity. So uniform motion or uniform velocity are when an object travels equal distances in equal interval of time. This is one thing. This is the definition of uniform. When an object travels equal distances in equal interval of time. Suppose 1 second, 1 second, 1 second. That is, the speed is constant, and this should be in a straight line and in one direction only. There should be no change of direction, and it should be in a straight line and in the same direction. Then we call it uniform motion or uniform velocity, and this is linear in a straight line. But uniform circular motion is quite different from this uniform motion. In here, the speed is uniform as well as velocity is also uniform. Velocity can change in three ways. In a non-uniform velocity can be non-uniform if the speed changes or if direction changes, or both, speed and direction both change, then the velocity will not be uniform. When the velocity is non-uniform, then the motion will be non-uniform. Speed may uniform in non-uniform velocity. How? Speed may be constant. Suppose a car is running at 15 km per hour in this direction, and again it changes the direction, but the speed remains 15 kilometers per hour. Again the direction is changed, then the speed remains 15 kilometers. So the speed is constant, but the velocity changed. Why velocity is changing? Because the direction is changing. So velocity can change by change in speed or change in direction or both. Then the velocity will be non-uniform, but speed may be uniform. This is with reference to linear motion. We have discussed this in detail in past videos. Today we will learn about what is uniform circular motion. Circular means when an object, it travels on a circular path or in a circle. Suppose an object, a car or an athlete or anything, it is revolving around a circular path. A park may be there, track may be there, and somebody, it is walking or traveling in circular motion. Then it is known as uniform circular motion. What is the specific characters of this uniform circular motion? That is, speed is constant. What does it mean? It means, suppose an athlete, it is running in this circular path at the speed of 10 km per hour, and throughout the path he is running with 10 km per hour. So speed is constant. So it should be uniform speed, but it is not uniform motion. Why it is not uniform motion? As velocity is changing. How velocity is changing? As the direction of the motion is changing. Motion is changing. How the direction of the motion is changing? Suppose that person starts from here. When he is going here, when he starts, his direction of motion is like this, northward. When he reaches at this point, his direction of motion is like this, westward. When he reaches at this point, his direction of motion is southward, and when he reaches at this point, his direction is eastward. So his direction is continuously changing, and this change is each and every point of circle. At every point he is changing his direction. When direction is changing, it means velocity is changing. When velocity is changing, then the motion is non-uniform. So we can say in this uniform circular motion, particularly the speed is constant, or we can say speed is uniform. One and the same thing, but motion is non-uniform as velocity is changing at each point, or we can say motion is non-uniform. And when non-uniform motion is there, then there is acceleration. So acceleration is there. If the motion is non-uniform, then it causes acceleration, and this acceleration is towards center of the circle, and it is known as centripetal acceleration. It is known as centripetal acceleration. What does it mean? That this is the center of the circle, then from all the sides the acceleration is at radius and it is towards the center of the circle, and any force which goes from periphery to center is known as centripetal. So this acceleration is known as AC, centripetal acceleration, or AC, centripetal acceleration. So when the due to non-uniform velocity, acceleration is caused, and this acceleration is towards the center. So this is a special type of motion. We call it uniform. We have to use the word circular. It is not uniform motion, not the linear motion. We have to use this word circular. So it is uniform circular motion, and the characteristic speed is constant but velocity is not constant. At every point the velocity is changing. Why? Because direction is changing in this circular path. This is one thing. Now the second is, if we want to know what is the direction of the motion at each point. What is the direction? So how will we prove what is the direction? Direction of the motion is, suppose the person is here. I will draw it again. What is the direction? This is the circle. Suppose the man or the object is here. This is the tangent on this point. A tangent is in that direction. So the motion of the object will be in the direction of the tangent. So motion will be like this. Suppose the person is here, tangent is like this, then the motion will be in this direction. This we will prove by a simple activity. Suppose a child is here this is his hand, and he is holding a string, and on this string a stone is tied, and he is revolving this stone in this circular way. So stone is going like this, like this, like this. He goes on revolving this stone. When he releases this stone at some point of time, if he leave this string and releases the stone, so if it is at this point, the stone will go in this direction. Why the stone is going in this direction? Because this is at this point, the tangent of this point is like this. The tangent is in this direction, so stone will go in the direction of the tangent. So this is the direction of the motion in circular path or circular track. Now what are the examples of circular motion, uniform circular motion? First, the important example is Earth revolving around Sun. This is also an example of uniform circular motion. The second example is artificial satellites revolving around the Earth. The very common, the simple example is hands of a clock. This is also an example of uniform circular motion. The speed is constant, but velocity is changing at every moment. At every point of the circle, velocity is changing. So this is about uniform circular motion. Now I will give you some formula to solve the numericals. Very simple formula of the circle. These are the distance travelled by the object in a circle. Distance travelled in a circle, all of you know, equal to its circumference. Circumference is 2 pi r. But it is 2 pi r n. What is n? N is number of revolutions around the path. It may be half, 1, 2, 3. So n is the number of revolution. This is the circumference of the circle. 2 pi r into n will give us the distance travelled by the body. Now speed, we can calculate distance upon time. Distance, we can calculate distance like this and upon time. Now displacement, all of you know is final velocity minus initial velocity. That the position at final position and initial position will give us, this is subtraction minus, will give us displacement. So you have to learn all these three formula: distance 2 pi rn, n number of revolution, speed distance upon time in meter per second, distance in meters, and displacement in meters. So we will solve these two numericals based on these three formula. Read the first one. An object takes half a revolution of a park. So n here, question 1, n is equal to 0.5. Half revolution is there. Radius is 7 meters. Time is 11 seconds. So first we have to calculate the distance. Distance s is equal to, distance is denoted by s, 2 pi r n. So it will be 2 into 22 upon 7 into 7 into 0.5, because he has taken half revolution. Half revolution is 0.5. This will be cancelled out. So it will be 22. What is that? Distance. 22 meters. So this is the distance traveled in 11 seconds. Now we have to calculate speed. Speed is equal to distance upon time, 22 upon 11 seconds. So speed will be 2 meter per second. Now the displacement, final velocity, final position. I should write final position minus initial position. So what is the, suppose this is a circle, this is 7 radius, so diameter will be 14. The person is here revolving like this and he has taken half turn, only half turn. So his final position will be, suppose he starts from A, so finally he will be at B after 11 seconds. So the smallest distance between A and B is 7 plus 7, 14. So the displacement will be 7 plus 7 is equal to 14 meter, or the diameter of the circle. This is the final position, this is the initial position, final minus initial, so it will be 14. So in this way we will calculate speed, distance and displacement in this numerical. Now we will do question number 2. The car takes 2 complete revolution. Here n is equal to 2. The radius is 14 meters. Time taken is 88 seconds. First we have calculate distance. S is equal to 2 pi Rn. 2 pi Rn. So n is 2. How much is this? 44, 88, 176 meters. So the distance travelled is 176 meters. The speed is distance upon time, 176. Time is how much? 88 seconds. So the speed will be 2 meter per second. Now about what is the displacement? Takes 2 complete revolution. The car takes 2 complete revolution. Suppose this is a park. The car starts from here, point A. This is 1 complete revolution and this is the second complete revolution. So after 88 seconds, the car comes at point A. So what will be the displacement? Final position minus initial position. Both the positions are same. So displacement will be 0. No displacement is there as both the position they coincide with each other. In this way, these 2 numericals are calculated. One we have calculated before also. So this is what we have to learn in uniform circular motion. This is all for today. Thank you.